So basically, declins are specific types of bicyclic molecules that can form chairs. And all they are is that they are composed of two cyclohexane rings fused together by one bond. So if you think back at the types of bicyclic molecules that we studied, this would be what we called a normal bicyclic. Okay? And the reason we call this one normal is simply because it does not have a bridge. Remember that normal just meant that there were two rings fused by one bond in the middle. All right? So what are the differences between these conformations? Well, because of the fact that the entire molecule is made out of just cyclohexanes put together, that means that each side can form its own conformer. All right? And what that's done is it leads to two different types of ultimate conformers that we need to know about declins. All right? And the way that we determine the differences between both is by looking at the positions of the hydrogens in between the two rings. So what we have is, I'll show you right now, we have trans declin and we have cis declin. All right? So what's the difference here? Well, trans declin is like it sounds. What it means is that the hydrogens that are attached to both sides of those bridgehead atoms, remember these atoms right here, are called the bridgehead. Okay? Okay, well, the hydrogens that are attached to the bridgehead atoms are trans to each other. What that does is it gives us a conformation where you basically have two cyclohexanes fused perfectly together, and you have one H at the top face, one H at the bottom face. All right? So this is what a trans declin would look like in a planar structure and also as a chair conformation. Okay? Now let's look at cis declin. Cis declin forms when we still have those bridgehead atoms, but both of the H's go towards the same side or the same face of the rings, okay? So what we wind up getting is you still have two chair conformations, but they're connected in slightly different way, where now one is actually basically going to go down or up, depending on how you draw it, and then the hydrogens are going to go face the same direction, basically. So what that means is we have two different arrangements. We could either have the H's facing different directions, or we can have them facing the same direction. Okay? Cis versus trans declin. Which of these do you think is going to be the more stable form of declin? What do you guys think? And the answer is that it's going to be trans declin. Okay? Because of the fact that we're going to have a lot less steric and torsional interactions in the trans position. Think about it. In this case, what I have is I have two rings that are as far apart from each other as possible. Okay? I also have pretty much no torsional interaction between this H and this H. They're as far away from each other as they can possibly get, so that's a really good declin. Now let's look at cis declin. Cis declin, what it has is that now these rings are kind of in each other's space. One is facing the same way as before, but now one is going to be facing down, and what that means is that there's going to be a little bit of interaction, a little bit of interaction between these guys. Okay? On top of that, now what we're going to get is a little bit of torsional strain between those H's, okay? So the cis declin is actually significantly less stable than the trans declin, okay? Now, what kind of questions will your professor ask? I honestly don't know. Not all professors talk about declins. Not all professors actually care about declins as its own subject, okay? But I have found over years of tutoring that some professors will want you guys to be able to draw these declins and to be able to say which one's more stable and which one's least stable.